Just confirm if you can see the whiteboard.
Yes, sir.
Okay. Okay. Now we just did that for an AR1 process. I'll just give you another example, and that's how we'll wrap it up. So let's say, yeah. Now let's say if you have done your ACF and PACF test and you have figured out that your uh, that the underlying stochastic process satisfying your data, which looks like this, is a ARMA 1-1 process. Is a ARMA 1-1 process, which is something like this. Is that okay? That's how it looks like. So this is ARMA 1-1, where all your ATs follow, let's say, normal, zero, sigma is there. Now, how will you do this? Well, the process is exactly similar. We will start conditioning. So you have your Y1, which is the first observation. Then Y2 is simply phi Y1 plus A1. Sorry, A2. Okay. So let's say Y1 is given. Then you're starting your stuff from here. So you have the past observation, yesterday's observation plus A2. Then you have Y3, which is phi Y2 plus A3 plus theta A2. Then you have Y4, right? This is how your ARMA 1-1 process looks like. Dot, 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 dot. Now, what do you need to find? You need to find the likelihood of this data. So we are going to proceed exactly in the same manner. So what is expectation of Y2 given its past, which is Y1? Tell me, what is it? It's simply phi Y1 plus expectation of Y2 given its past. But A2 is not connect expectation of A2 given Y1. Let me write this. So this is phi Y1 plus expectation of A2 given Y1. But A2 is today's randomness. The today's randomness conditioned on what happened in the past is simply expectation of A2. It's independent of the past. It's today's randomness. And that is 0. So this is simply phi Y1. Okay. Similarly, what is variance of Y2 given Y1? That's simply, as we had done before, expectation of Y2 minus expectation of Y2 given Y1 square. That's simply expectation. But A2, as I mentioned, is not connected to its past. It's today's randomness. Yes, Mutiyar? Is that right? Abhyuday? So I can infer that Y2 given
Yes,
Y.
sir.
Is that okay? That's a safe thing to infer. Now let's call this. Okay, fine. Let's put it this way. Now let's try to find out for y3 given y2, y1, y2. So if I ask you what is expectation of y3 given y1, y2, it's past. What will that be? Can somebody tell me? What is y3 again? It's ARMA 1-1 process. So y3 is 5y2 plus a3 plus theta a2. Okay. So expectation of y3 given y1, y2. This is simply 5y2. What is expectation of y2 given y2? It's just 5y2. What is expectation of a3 given y2? So you have 5y2 plus expectation of a3 given y1, y2 plus theta into expectation of a2 given y1, y2. Okay. Now what is this? This is simply 0 because this is expectation a3. So you have 5y2 plus this guy. Now what is this? Can somebody tell me? What is expectation of a2 given y1, y2? What
A2.
was that's correct. It's simply a2 because I know a2. If I know y1, y2, what is y2? Y2 is 5y1 plus a2, isn't it?
Yeah.
And then you had a3 is, sorry, y3 is 5y2. I'm just writing it down once more. Plus a3 plus theta a2. Dot, 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 dot. So once you know y2, you basically know a2. If you know y1, y2, you know a2, which is what? y2 minus 5y1. So this is simply theta which is your a2. The realized a2, right? You know it now. Is that okay? Is it clear? Is it clear? Vaibhav?
Yes, sir.
Great. Now, if you know this, what is variance of y3 given y1, y2? It's again expectation of that. So it's y3 minus expectation of y3 given y1, y2, which is simply this plus this. So if you subtract, what do you have? Expectation of a3 square given y1, y2, which as we had done previously, proceeding similarly, it's sigma a square. Is it correct? Do you see what I'm doing? Abhyuday, do you see what I'm doing?
Yes, yes.
So now you've found y3 given y1, y2. This follows what? So now you know y3 given y1, y2. This follows what? This follows normal. This thing, whatever you call it, let's call it G3. Just name it that way. Sigma a square. Is it okay? Or let's call it mu3. Why call it G3? Such a bizarre name to give. Mean is usually mu, right? So this is mu3. What was y2 given y1? It was, let's say, normal mu2 sigma s square. And what was mu2? Do you remember? What was mu2? It was simply 5y1. Mu3 is this. Do you see what do you see this clearly? So now you have y2 given y1. You know the distribution of this. That's simply normal mu2 sigma s square. Then you have y3 mu3 sigma s square. ठीक है? Where mu2 is 5y1. Here your mu3 is what was that? 5y2 plus theta y2 minus 5y1. Correct? Similarly proceeding, find y4 given y1 up y1, y2, y3. That will be some normal with mu4 sigma s square. Find that mu4. Clear? And proceedingly, you can do this. You can go up to y capital T. Can you do this? This is your homework. T minus 1. Yes, Abhyuday? Do you see this?
Yes, yes, yes.
Okay. Now that you know this, if you can find all of these, now you have the usual shit, which is just you have this y1 to yt. Correct? That's the usual drill which you have. This is y to yt minus 1. Yes, isn't it, sir? Then you have yt minus 1 given yt minus 2 dot 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 dot. And you know all these densities by in this manner. Yeah. So in that way, you can find the likelihood of this data. This is your likelihood function now. Is it clear? Is it clear? Ananya, is it clear?
Yes, sir.
And what is your likelihood function a function of? What are the parameters? Somebody tell me.
The mu and sigma square.
Say it again. Say it again.
Okay, phi and theta.
Phi, theta, and sigma is square, right?
Yes.
And you maximize this likelihood with respect to these parameters, and then you know the model. Then you know the parameters of your ARMA 1-1 model. Is it clear? Everybody, is this clear? Any questions? Any questions? Anyone? Any questions? Hello. Anyone? Any questions?
No.
No, right? Good. I wish I could be more, elaborate in the time series thing, but I guess I have to just wrap up in 3-4 hours. There's the paucity of time for you. The semester is way too short. Anyway, so that's where we end. That's where we kind of end the semester. We have 2 more days when we are going to meet. As I mentioned yesterday, one is Thursday from 5 to 6 and Friday from 3 to 6. So these will be student presentations where your friends are going to take your classes. So there will be 4 sessions. There will be one session where I think Abhyuday is going to teach discrete choice models. Aditya will teach principal component analysis. Karthik will teach estimation, and Ananya, you are going to teach two-bit
The
model.
2-bit model.
Yeah, Ananya will teach two-bit model. Okay, so I'll send out a formal email tonight, informing everybody about this. And the class will happen in the usual classroom, which is NR 223. Okay. Okay, then, guys, I'll wrap it up. Any questions? Something you'll want to ask? Otherwise, I'll end the meeting. Alak, do you have a question? Niharika, Alak, you guys have been silent.
No, sir.
Okay. Okay, then. Chalo. I'll end the meeting. I'll see you guys on Thursday.
Sure. Thank you, sir.